I think maybe 2 of you have gotten it and have given me faces that you've gotten it, and everybody else, including Caitlin, is giving me a very frustrated face. Okay, so let's talk about ACT scores. Is that too fresh? Okay, let's talk about something that doesn't matter. Let's talk about that. Let's talk about shoe size. Is that better? Okay, shoe size. Here are the shoe sizes of people in this school. You got some people who got little tiny feet, little tiny baby feet. You got some people who got some giant feet. Okay, most people are sitting here in the middle, but we've got some extremes here. Now imagine if I had everybody throw their shoes in a pile. Okay, we got a huge pile of shoes. No, we're not gonna do it. So let's say we have a huge pile of shoes, and I start grabbing 10 shoes out of the pile at once. Now I've got 10 shoes in front of me, and I look at all the sizes, and I try to hold my breath, and I add up all the sizes and I divide by 10. What are the chances that I happen to grab 10 of the smallest feet in the school? Unlikely. What are the chances I grab 10 of the tallest or of the largest feet? Unlikely. So when I start, then I make a new list, and my new list has all these averages. So my new data set, instead of having all the shoe sizes, it's all the averages of the piles that I grabbed. Okay? So now when I grab it again, when I graph it again, it's going to look like this. It's still a bell curve. It was a bell curve originally, and it's still a bell curve now. And that middle number is still the same. That mean is still exactly the same, but see that standard deviation got a lot shorter. Is this helping?
Yep.
Okay. What's the point of this? The point of this, that's a good question. That's like a really good question. Okay? The reason why they look at averages of stuff is because bell curves have specific math associated with it. We have this chart. This was created with calculus, with area under a curve. That's what calculus is, PS. It's finding areas under curves and being able to graph curves rather than graphing straight lines. Straight lines are easy, that's algebra. Okay, but when it comes to curves that change and aren't like a parabola, but actually change, that is calculus. And it is something that is easy to do if you know what calculus is. And that's where they got all of these numbers, okay? So this math is like exact. I can tell you exactly what the 95th percentile is. But if I have a whole bunch of cell phone bills and it doesn't look like a bell curve, then this doesn't mean anything. But if I start grabbing groups of 10 and looking at the averages, then I can give you exact percentiles and figure that out and start making judgment calls, which is what companies want because they want to know how much money they have to spend and how fast things are selling and what's going on. So basically, this is a trick to make things into bell curves, which make things easier for statisticians.
Something that's not a bell curve.
Into a bell curve, yeah.
To use that, okay.
Exactly. Okay, still trying. Here we go. The new z-score formula. Now, normally, it's z equals x minus mu over sigma, but it's not sigma this time because the mean is still the mean, right? The mean is still the mean, but what is sigma changed to? The standard error, which is sigma divided by the square root of n. So the only difference here is that when you see we're talking about the mean of means, instead of using x minus mu over sigma, you use x minus mu divided by sigma divided by n, the square root of n, which is not at all a fun song. And to be honest, the first one's not really a catchy song either, guys. It's not. But I'll put it out like on an MP3 someday and sell it at 2 cents a pop and get like 8 cents. I'll throw on a whole bunch of extras. Maybe I'll make an album, like, you know, with classics like "Are You Doing Your Homework?" and stop that. Okay, the average amount of time a 15 to 19-year-old spends driving. Anybody want to take some guesses?
25. Average
No,
time.
30, at least 30.
Driving.
How many years ago was this made?
This was made 2015.
1 hour.
Okay, so it's most definitely
60
higher than
minutes.
No, 30 minutes.
I'll say 20.
25 minutes,
30.
12.
It's 25 minutes, and standard deviation is 1.5 minutes, so way off there, but hey,
That's,
this one was 15 minutes, and also, you know what's extra funny, or sorry, 25 minutes, sorry, 25, not 15. And you know what's really funny, Ryan, is that it says that it's the standard deviation right there. So, average amount of time a 15 to 25-year-old spends driving every day is 25 minutes. You randomly select 50 drivers, ages 15 to 19. What's the probability that the mean time, do you see, this is the hint that it's a central limit theorem question. What's the probability that the mean time they spend driving is between this and this? All right, I know that because we're looking at the mean of means, I can draw a bell curve. Sounds like the Game of Thrones, doesn't it? Mean of means?
Yeah.
Dun 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 dun. Here's 25. No one likes Game of Thrones?
I haven't watched it.
Shame on all of you.
My dad said
You
it's
telling us to watch a show that kids you to watch, that's all.
It's actually like pretty sexualized, so maybe I should just shut up. Shame on you guys. Watch inappropriate things. As I record myself saying that. All right. This looks very much like the last one, right? X minus mu over sigma, only it's not sigma. It's sigma divided by the square root of n. So now, I know, it's not as catchy. You need to come up with a new x minus mu. Divided by square root of n. All right, so we're going to do two equations here. This is 24.7 minus the mean, which is still 25. The bottom is that 1.5 divided by the square root of n. And they said that they select 50 drivers. When you put this in your calculator, make sure that the top and the bottom are in parentheses. Yep. Negative 1.41. What else do we need to do? Mm-hmm. 25.5 minus 25 divided by 1.5 divided by the square root of 50 again. P.S. Learn lessons. Be smart. Look up. Hit second enter. It brings back the exact same thing you just typed in. Just change that 24.7 to 25.5. It's a time saver. I got 2.36. And what are those numbers?
Z-scores.
Those are z-scores. So how do I find the area between those two?
Look on the sheet.
Look on the sheet. When I look this up, am I looking on the outside or the inside?
outside.
Outside, negative 1.41. For negative 1.41, I got 0.0793. You guys the same? Anybody confirm?
Sheet again?
Yeah, that's it.
0.0793?
Yeah, that's right.
And then flip it over, 2.36. I got 0.9909. Has anybody noticed that it is really helpful that they alternate blue and white? Yeah, that's why I did this in color when I copied it for you, so that it would be, I don't know, but even the blue makes a big difference compared to just gray for
Was the
being,
intro to stat one's colored?
what?
Was the intro to stat one's colored?
Yeah.
I think so.
I thought it was.